welcome to Mann Maker. I am Ranjan Kumar and today we are going to solve BL previous year question which was held on 31st May 2025 for BL Probationary Engineer, and this paper belongs to Electronics Engineer. Okay, so we are going to solve this question with details explanation. We will do all the question we are going to solve in a details way, and at the last we will do analysis and we'll see the weightage of question, and we'll also see the level of your exam. Okay, for PDF and more updates you can join our Telegram channel, and this is my Telegram channel name and WhatsApp group. You can join both of these. Here I am updating class, job update, PDF notes, study material you will get here only. Okay, and now you can download the Mann Maker app from Google Play Store. There in that you can access your course. Okay, which is like you can get this probationary engineer app material, all this material in the app only. So you just need to go there, download this one, and if you are preparing you can take and prepare for that. Okay, so as we are so today we are going to solve this 2025 paper BL Probationary Engineer. So already we have covered general aptitude part in the previous class I have solved this general aptitude question. So today we are going to solve technical part that is related to your electronics branch, and already for 2023 paper I have solved and I have uploaded in the playlist. I think you have gone through that, and who haven't seen till now, just go and check that class also, where I have discussed 2023 previous year probationary engineer paper for electronics branch. Just check that question level of 2023 also, and here we are going to solve today 2025 paper. Okay, so we'll start with question number one. We are going to start. Okay, number system contributes to error reduction in digital communication system. Okay, if we talk about our binary number system, so binary number system plays a vital role in error reduction because it's allowed only 0 and 1. Okay, two distinct state is there, that is your 0 and 1. That's why in a binary system it is in a binary system it will be like it will play major role to find the error reduction. Okay, so in binary system, when extra bit is added to a binary word, okay, when we will add extra bit to a binary word to make the total number of ones either even or odd, either we will make even or odd. Okay, so this extra bit we will call as a parity bit. When we will add extra bit, that we will call parity bit, and by adding this the total number of ones either become even or odd. So this, if it will become even, then this will called as a even parity. Okay, and when it will become odd, then it will called as a odd parity. Okay, so from here we can say like binary number system contributes to error detection in digital communication by using parity bits to detect single bit error. Okay, generally we will use parity bit to detect the error in a binary system. Okay, so option A is your right answer. Which Boolean law is represented by the equation A dot B plus C? Okay, what is given? A dot B plus C equal to A dot B plus A dot C. Okay, this is given. I mean, this is which belongs to which law? So this is generally belongs to distributive law. Okay, just remember this thing, 1 dot 2 plus 3. Okay, 1 dot 2 plus 3. So it will be 1 2 and 1 3. Like this, if you remember, then it will like if you want to remember distributive law, you need to remember 1 2 plus 3. So 1 2 and plus 1 3. Like this, you remember. Okay. So from this, option C is your right answer. We have this law like idempotent law we have. So generally it will be A dot A is equal to A, or you can say A plus A equal to A. Okay, if you got this thing, then it belongs to this law. Now we have commutative law. So commutative law, how we will display commutative law? So it will be A dot B is equal to B dot A, and you can say A plus B equal to B plus A. Okay, distributive law we already discussed. This will be A dot B plus C and equal to A dot B plus A dot C. Okay. And when we talk about associative law, so associative law is your A dot B C equal to A dot B dot C. Or you can say one more thing is there, like OR get A dot A plus B and plus C equal to A plus B plus C using OR operation or OR operator. So this is associative law. So like this, you need to remember all the laws. They will ask questions sometime like that only. They will give some equation and they will tell which law it belongs to. So you need to remember all the things. Okay. Now, which of the following step is essential in minimizing a Boolean function using K-map or Karnaugh map? Okay. So K-map is usually we will use to it is a minimization technique, as we know. So here whenever we will talk about either for two variable, if it will be two variable, then we will make like this box A and B. So there will be four boxes there, and if we have three variable A B C, then there will be like this, we have eight boxes, and if we have four variable A B C D, then it will go 16 boxes. Okay, like that it will be there in a K map. So generally you can say 2 to the power, 2 to the power something, 2 to the power. If you want to prepare this like if you want to make a box, like if whatever value variable is there, suppose two variable, so it will go 4. 2 to the power 3 means 8, and 4 variable means 2 to the power 4 equal to 6. Okay, and the thing is, what we will do, how we are how we will do this grouping and all. So generally we will make 1 or 0, like that we will make, and we'll do pairing. Either we will do pairing, either we will make quad, or either we will make octet. Okay, these are the pair. So basically we will make a group of ones. So you can say option 1, it is written plotting the min term of the function into the K map and grouping adjacent one into a power of 2. Okay, correct. So same thing I explained. So option A is right answer from here. Okay, now question number 3. So it's related to control. Okay, a control engineer design a leg lead compensator where the poles are at s equal to minus beta by t1 and minus 1 beta t2, and zeros are s equal to minus 1 by t1 and minus 1 by t2. What condition is true for the parameter beta is lag lead concern compensator? Okay, so for lag lead, for if we talk about for lag lead, as here it is given poles we have, that is here it is mentioned s equal to minus beta by t1, and this one is minus 1 by beta t2. Okay, two poles we have. Similarly we have zeros also. So zeros it's given as equal to minus 1 by t1, and this one is minus 1 t2. Okay, this one is this one it's given. Okay, so for lag lead compensator, first we need to understand about lead compensator and lag compensator. Okay, so when we talk about lead compensator, okay, lead compensator. So lead compensator generally how we will show, so it will be for lead it will be as equal to, this is k 1 plus s t1 and divided by 1 plus s beta t1. So in this case, when it is lead, so in this case, this beta is less than 1. Okay. So, so in this case, 0 is closer. In this case, 0 is closer to origin. Okay, in this case 0 is closer to origin. And when we talk about our leg compensator, okay, leg compensator, so in leg compensator we have G leg and S equal to, this will be K 1 plus S T2 divided by 1 plus S beta T2. Okay, so in this case, this beta is greater than 1 and pole is closer than the 0. Okay, so this is the two condition of lead and lag. And here they have asked about lag and lead. So lag and lead, in lag and lead both will come. This lag will also come and lead will also come. So for lag it will be beta is greater than 1, and for lead it will be beta is less than 1. Okay, as it is lag lead, okay, as it is lag lead compensator, so beta should be positive, means beta should be greater than 1. So option D is your right answer. Okay, so beta will be always positive because it's a leg lead compensator. Now the next one is, in a gray code to binary converter, in a gray code to binary converter, how is the most significant bit MSB of binary code determined? So either it is binary to gray converter or gray code to binary converter. Anything will be there. Like while we are doing gray to binary or binary to converter, generally this MSB we will make as it is. We will take as it is. Okay, if it is 1, then it will also 1, no change is there. After that we will do XOR operation while doing next process. Okay, same we are doing binary to gray also and gray to binary also. Our MSB, that most significant bit, will be same as it is the question. So from here we can say option B, as it is mentioned, it is equal to the MSB to the gray code input. So whatever gray code input is there, same input you will get in a binary also. If they have asked for binary to gray also, so same binary, whatever number it was given in a binary number, same thing you will get in a gray also. Okay, so this MSB is always same. Okay, option B is your right answer. How does the triggering mechanism differ between the latch and flip-flop in a digital circuit? So triggering we are using in both cases, latches and flip-flop. Okay, so a trigger is used in both things, like latch also. Okay, in latch we are using trigger, and in flip-flop also we are using trigger. But in latch we are using label trigger, and in flip-flop we are using as trigger. This is the difference only. So option C, a latch is label trigger, and while flip flop is a as trigger. Okay, so option C is your right answer. Okay. Which of the following is a primary advantage of using milli machines, okay, milli machines over a more machine in FSM design? FSM design means what? FSM design means what? FSM means finite state machine. Okay, in finite state machine, what is the primary advantage using milli machine over a more machine? So generally if we talk about our more and milli, okay, more and milli machine, if we see the difference, so our output here in a more, output it on depends on current state only. Okay, current state only. In current state, in a more you will get the output will be depend on current state only, but in the melee it depends on, output depends on current state. Okay, current state and input state. Okay, this is the difference of output. Okay, and one more thing, output changes on state transition in a more. Okay, transition. Okay, so in a more machine, output changes on a state transition, and in a melee, output changes immediately. Immediately with input changes. Okay, this is the difference of output change. And number of state, if we talk about number of state, so number of state is more in more, and number of state is fewer in melee. Okay, and response time, if we talk about response time, so response time is slower here in more and faster in the melee. So this is the main, actually this is the primary advantage. Okay, this is the main advantage of this thing. Okay, so we can say from here, what they have asked about about it asks primary advantage using primary advantage, it's asked using a melee machine over a more machine. So melee machine is a faster, you can say a more machine is a faster, or you can say fewer state is has this b1, a melee has a fewer state, and more has a more state. Okay, so this is the main different. All right, or better answer is option C, because you can say it asks of over more. So over more, basically it's asked the advantage of melee. So melee has a faster response. Okay, melee give the faster response, so the synchronization will be more accurate. So your answer will be option C. For so the question number 7 answer will be option C, because melee give the faster response compared to more machine. Okay, now which of the following best describe a situation where a bidirectional shift register would be preferred over a unidirectional shift register in a digital system? Okay, so if we talk about our shift register, if we talk about our shift register, a shift register is a group of flip-flop that is used to store or shift a binary data. Okay, it is a group of flip-flops. Okay, shift register are group of flip-flop used which is used to store and shift binary data. Okay, this is the definition of shift register. So basically we have unidirectional. What they have asked about unidirectional, bidirectional, why we are using bidirectional? Because in unidirectional, okay, in unidirectional shift register, it will shift data only one directional. Okay, it will only one directional. It will shift the data only one directional. Either it will go left side or either it will go right side. So only one directional it can do. But in the bidirectional, but in the bidirectional, it will go both way. Okay, both way or both directional it will go. Either it will go left and right depending on the control input. It will go left also, it will go right also, means both direction it will go according to the control input. That's why we are choosing bidirectional shift register in a digital system over a unidirectional shift register. So from here you can say shift both way or rotate the data. Shift both way or rotate the data. Option B is your right answer, because it is going both direction. That's why we are using bidirectional. Okay. Now the next one is, which of the following is a common application of VCO? VCO means what? Voltage control oscillator. Okay, so if we talk about our VCO, that is your voltage control oscillator. So voltage control oscillator is an oscillator only whose output frequency is controlled by a input voltage. Okay, output frequency is controlled by input voltage. Okay, output frequency is controlled by input voltage, and it is used in, or you can say example, where we are using phase I mean this VCO. Generally we are using in phase phase looped loops loops, or FM modulator, FM modulator, or you can say signal generator. Okay, signal generator. Okay, so we are using this VCO in PLL, that is your phase loop, and FM demodulator also, and signal generator also. One more thing you need to remember, it generates it's generate a periodic waveform. Okay, VCO generate periodic waveform like sine, square, or triangular. Okay, like that periodic waveform it will generate. So here they have asked which of the following is a common application. So our common application here, signal generator in frequency synthesizer, you can say, because I have some more example is there, PLL, FM demodulator, signal generator. So option B is your right answer. Okay, apart from that you need to remember that thing also. Sometimes they will ask what kind of signal in which form signal will generate in VCO, either it is periodic or aperiodic, unperiodic, or non-periodic. So you need to give an answer as a periodic waveform. Okay, what element are included in frequency spectrum of AM signal produced by an sinusoidal modulating signal? Okay, when we see the spectrum diagram of AM, so this we called FC, that is your carrier frequency, and we have two side bands. Okay, side bands is also there. This we called FC minus FM, and this we called Fc plus Fm. Okay, so this is what, this is your carrier frequency. Okay, carrier frequency, and this is called upper side band, and this is called lower side band. So generally what element are included? So here option B, carriers and sidebands are included in the FM signal. Okay, you need to give answer like that. Now the next one is, a term is testing various material that are to be used in electronic device. Team chosen one of the material having resistivity range of 50 ohm per centimeter. Which type of material did the team choose? If we talk about our material, so generally material we have three types. Okay, that we know already. It's our conductor, then we have semiconductor, and we have insulator. Okay, and if we see the ranges of like conductor, for conductor generally conductor will called as a low resistive. Okay, low resistivity, it has low resistivity. Okay, it has low resistivity, that's why more conductivity is there. And semiconductor have a moderate resistivity is there. Okay, and in insulator high resistivity is there. In insulator high resistivity is there, that's why less conductivity is there. So if you see the range of conductor, it will go 10 to the power minus 8 to 10 to the power minus 4 ohm per centimeter, and for semiconductor it will be 10 to the power minus 4 to 10 to the power 8 ohm per centimeter. Then for insulator, it will be 10 to the power 8 to 10 to the power 18 ohm per centimeter. So from here they have used 50 ohm per centimeter, which will come under semiconductor. So option B is your right answer. Okay, semiconductor is your right answer. Now the next one is a semiconductor based current sensor is used for detecting small variation in electrical current in a microchip. A total current density in a semiconductor material is to be measured. What is that total current density in a semiconductor material? Okay, so basically they have asked this thing only. What is the total current density in a semiconductor material? Okay, so in a semiconductor, current is carried by two type of charge carrier. Okay, in semiconductor, current is carried by two type of charge carriers. Okay, carriers, that is your electron. Okay, and another one is your hole. Okay, electron and hole. Electron having negative charge carrier and hole having positive charge carrier, and each this both will contribute to the total current. Okay, total current through the current density. Okay, and generally we will calculate the total current density the in semiconductor, that will be the sum of electron and hole, that J equal to, we will write Jn plus Jp. Okay, Jn is what? Jn is your drift current, and Jp is your diffusion current. Okay, so from here we can say it is drift current or current density. Total current density is what? Total current density of a semiconductor is a summation of drift current and diffusion current. Option C is your right answer. Okay, now the next one is, consider a photodiode with P plus I minus P minus N plus configuration. This construction is similar to pin photodiode containing two heavily doped and two lightly doped regions in the avalanche photodiodes, that is APD. Which of the following are the heavily and lightly region in the device? Okay, so in avalanche photodiode, that is your APD, that P plus and N plus is or are called heavily doped region. Heavily dot region. Okay, and we have I and P, that will that are called lightly doped region. Okay, so from here we can say option C we have or option D. Option D we have P plus and N plus are heavily doped region, whereas I and P are lightly doped region. Option D is your right answer. Okay. Now, question number 14. For fabricating an integrated IC, I mean integrated circuit, which oxidation method should be chosen to achieve a faster oxidation rate to creating thick silicon dioxide, that is SiO2 layer in 1 micrometer while expecting a higher density of interface state? So generally we are using oxidation for this IC fabrication. Weight oxidation we are using. Okay, for a faster oxidation rate we are using weight oxidation. In the dual well process or twin tube process, during step 9, ion implantation is performed to drop a source and drain region of the PMOS and NMOS transistor. Which of the following is formed as a result of ion implantation? during step 9 of dual well process of or twin tube process. So if we talk about our dual well process or twin tube process, CMOS, for CMOS fabrication process. So in that both N well and P well are connected in the same subtract. Okay, N well and P well are connected in same substrate. Okay, same substrate it will be connect. So generally what will happen for NMOS devices, it will build in P well. Okay, and for PMOS devices it will built in N well. Okay, it will built in N mode. And source 9 as step 9, as they have mentioned step 9. So step 9 is what? Step 9 is your source drain. It is your source drain formation. This we called source drain formation by ion implantation. So this is what step 9, source drain formation by ion implantation, and in this N plus region are implemented for here N plus region implemented N plus region implemented for PMOS. Okay, for PMOS, and P plus region implemented for NMOS. Okay, PMOS source or drain, N plus region implemented by PMOS source or drain, or P plus region is implemented by NMOS source and source or drain. So from here we can say option D we have. There it they have mentioned P plus polysilicon gate for NMOS and N plus polysilicon gate for PMOS. Okay, N plus for PMOS and P plus for NMOS. So from here you can say this is your answer. Okay, option D is your answer. All right. In the fabrication of semiconductor device using the dual well process, same question again they have asked. In the fabrication of semiconductor device using dual well process or twin tube process, the first step involve depositing a thin layer of SiO2 on a P substrate surfaced with a lightly doped P epitaxial layer. What is the purpose of the thin SiO2 layer in the first step of dual well process or twin tube process? So generally in the dual well twin tube process, the first step after cleaning the wafer is to glow or deposit SiO2 layer. Okay, what we will do, like after first step in a dual well, after first step it will go to SiO2 layer. Okay, we'll do deposit to SiO2 layer. So the silicon dioxide layer serves as a making or protecting layer during the ion implantation and oxidation step. Okay, what we will do in SiO2 oxidation, this will we do, it will be make as a protective layer, protective layer during ion implantation. Okay, and oxidation oxidation step. Okay, like what it will do, that SiO2 layer, deposit of SiO2 layer, it will serve as making a protective layer during the ion implantation and oxidation step, and which we called pad oxidation, which we called pad oxidation. Okay, which we call pad oxidation. So option A, it will serve as a pad oxidation. Option A is your right answer. Okay. Now the next one is in a small signal equivalent circuit. In a small signal equivalent circuit of a diode, what is the primary parameter that determine the small signal resistance of a diode? So small signal resistance. If we talk about small signal resistance, that we represent as a RD, and RD is equal to NVT by ID. Okay, where this VT is your thermal voltage. Okay, that is nearly equal to 25 milliwatt. And ID, we have ID is a DC current through diode. Okay, ID is a DC current through a diode. So from your option you can see option B is the thermal voltage and the diode DC operating system. Okay, so small signal resistance is what? It is the thermal voltage. Actually this is the formula they have to give as a ratio on the option, but they have mentioned thermal voltage and diode DC operating current only. So option B is right answer. What is the primary function of the tank circuit in a sinusoidal amplifier such as Colpit oscillator? If we talk about our tank circuit is a like a resonant circuit only. Okay, tank circuit is a resonant circuit of LC. Okay, in that they are using L and C, which are connected in a parallel or series. Okay, how tank circuit will be look like? Tank circuit is a resonant circuit which consisting of L and C. Okay, and it's connected in parallel or series. Okay, it's connected parallel or series. So in a Colpit oscillator, the tank circuit usually consists of one inductor. Okay, one inductor will be there and two capacitor will be there in series. Okay, in series from a in a Colpit's oscillator. So in Colpit oscillator, tank circuit is usually consist of one inductor and two capacitor in a series. Okay, and the primary function of the tank circuit is to select or determine the frequency of a oscillation from a oscillation by a reasoning or a specific frequency you can say. So the function of tank circuit you can say it will select or determine the frequency. Okay, it will select or determine the frequency of the oscillation. This formula is also there. Frequency is equal to 1 by 2 pi root under LC equivalent. So this is the formula for selecting the frequency in a Colpit oscillator for a tank circuit. Option A is your right answer. Now the next one is, what is the purpose of Zener diode in a voltage reference circuit? So generally Zener diodes is operate in a reverse breakdown region that we know all. Zener diode is operates in reverse breakdown region. Okay, it will operate in a reverse breakdown reverse and it's provide a stabilized voltage. So we can say it will provide stable reference voltage by operating in a reverse breakdown. Option B is your right answer. Now the next one is, why is the transconductance of MOSFET amplifier considered a key parameter? Okay, why is the transconductance GM of a MOSFET amplifier considered a key parameter? Transconductance. So, if we talk about our transconductance, so transconductance represents the ability of the transistor to convert a change in gate to source voltage into change in drain to current. Okay, basically this GM or transconductance, we have DID, that is your change in drain to current, and change in voltage to sorry, change in voltage in gate to source voltage. Okay, and it will be measured and Siemens. Okay, or you can say moho, like this. Okay, this is the symbol, symbol of Siemens. Okay, so here it's asked about what is the key parameter. So the key parameter is, it is defined as the ratio of change in output current to the corresponding input voltage. This voltage is what? This is voltage input, and this one is your output and input. This is the ratio. Option B is your right answer. Okay, now the next one is, what causes the gain of a BJT amplifier to decrease? Okay, at low frequency, generally frequency we have BJT. In a BJT amplifier we have three kind of frequency. Like if you see the diagram is also like that, it will go constant here, and again it will decrease here, also it will decrease. Okay, so this we will call low frequency, this we will call high frequency. Okay, this we call high frequency, and here this we call constant frequency, or mid mid frequency. Okay, mid frequency we call. So low frequency at low frequency, the gain will be, at low frequency gain will be decreases due to coupling capacitor due to coupling capacitor and bypass capacitor. Okay, at low frequency gain will be decreases due to coupling capacitor and bypass capacitor effects. Okay, and at mid frequency, if we talk about mid frequency, in that gain will be constant. Okay, gain will be constant. Okay, in this gain will be constant due to capacitor act as a short circuit. Okay, due to capacitor act as short circuit. Here in the mid frequency, capacitor act as a short circuit, that's why its gain is always constant. At high frequency, again gain will decrease. Here you can say in low frequency also it is decreasing, and in high frequency also it is decreasing. So in both the cases gain is decreasing due to parasitic capacitor parasitic capacitance or Miller effect. Okay, or Miller effects, due to two things, like either parasitic capacitance or Miller effect, the gain is decreases and the high frequency. All right, so here they have asked about what? At low frequency. So at low frequency it will like gain will decreases due to coupling and bypass capacitor. Okay, if they have asked for mid frequency, that time you need to give due to capacitor act as a short circuit. If they will ask for high frequency, that time you need to tell either belong to Miller effect or parasitic capacitance. Due to that only gain will decreases in the high frequency. Okay, in MOSFET amplifier, what is the primary reason of the upper cutoff frequency? Okay, same thing, upper cutoff frequency or high frequency. This is what, this is your this one is your upper cutoff frequency, this one is your lower cutoff frequency. So upper cutoff frequency, it will happen due to Miller effect or parasitic capacitance. Okay, so here option B is there, you can tick mark option B. In a MOSFET amplifier, what is the primary reason for the cutoff upper cutoff frequency? Due to Miller effect only this upper cutoff frequency will. Okay, what is the primary advantage? What is the primary advantage of the differential amplifier over a single stage amplifier? Okay, so if we talk about our what differential amplifier, so differential amplifier amplifies the difference between input signal. Okay, it will amplifies between two input signal, that is B1 and B2, while rejecting any voltage that common to both, any voltage that common to both. Okay, so this will be your V naught equal to AT V1 minus V2. This is the formula. So this is the main advantage actually, because it will what it will do, it will amplify the difference between two input signal, and it will and also it will reject the voltage that is common to both of them. So rejection noise is good here in the amplifier, in differential amplifier over a single stage amplifier. That's why this is the advantage for a differential amplifier, it will improve the noise rejection. Okay, now question number 24 is what, why does the gain of a BJT amplifier reduce at the high frequency? As we have discussed before also, at the high frequency it will be either Miller effect or parasitic capacitance is there. Due to that only the gain will decreases or reduces in the BJT amplifier. Okay, due to parasitic capacitance or Miller effect. Okay, so that is the answer. Why which type of, next question is what, which type of VCO, which type of VCO is typically used in electronic beepers? Okay, so VCO is what, voltage control oscillator. As we have discussed before also, this VCO is an oscillator, in oscillator where output frequency can be varied by the input control voltage. Okay, that we know. So type we have VCO type we have, some types are there, like we have RC VCO we have. Okay, then we have LC VCO. Okay, then we have crystal VCO we have, and we have ring oscillator VCO we can say. Okay, this RC VCO we are using in generator, in beeper, and function generator. Okay, and LC-VCO we are using generally in RF oscillator. Okay, in RF oscillator we are using, and cluster VCO we are using in microwave or RF source. Okay, in microwave or RF source we are using crystal oscillator VCO, and ring oscillator VCO we are using in PLL, that is phase loop, and in ICs. Okay, so these are the example of this type of VCO. Next time if they will ask any kind of question related to any type, that time you need to remember this thing. Here they have asked for beeper, so beeper used by RC VCO. So RC VCO means what, this one only, relaxing oscillator. Okay, relaxing oscillator, RC is relaxing oscillator. So option C is your right answer. Okay, now the next one is, what is the key advantage what is the key advantage of active filter over a passive filter? So the main thing is like active filter, if we talk about active filter, it uses active elements. Okay, it uses active elements like we have op amps, BJT, diodes. So these are active element which are used by active filter, and same as a passive filter. So passive filter uses passive element like we have RLC, resistance, inductor and capacitor. Okay, so the thing is, active filter, the main advantage of active filter is what it uses active elements. That's why it has ability to provide gain and precise control over a filter characteristic. So option C is your right answer for this answer question. Okay. Now the next one is, what is the primary purpose of sinusoidal amplifier in electronic circuit? So what is the primary function of a what is the primary purpose of a sinusoidal amplifier in an electronic circuit? That will, it will produce the sinusoidal signal with a minimal harmonic distortion. Okay, in the sinusoidal there is a minimal harmonic distortion is there. That is the primary purpose of a sinusoidal amplifier. Okay, it produces sinusoidal signal with a minimal harmonic distortion. Option B is your right answer. Next one is, which op amp configuration is commonly used as a voltage follower to provide high input impedance and low output impedance? Okay, so generally we are using non-inverting amplifier. Non-inverting amplifier is there, that is used as a voltage follower, and it will provide high input impedance and low output impedance. Okay, and this voltage follower, it is also called as a buffer. Okay, it also called as a buffer or voltage follower. Okay, this non-inverting amplifier is also known as a voltage follower or a buffer. Next one is, what is the purpose of a modulation feature in a function generator? So if we talk about our function generator, so some function generator is produce various type of waveform such as sine waves, square wave, triangle wave over a wide frequency range. So function generator will generate sine wave, square wave, triangular wave. So like that, it will produce various type of waveform over a wide range of frequency. And modulation, what it will be do, it will change the carrier of it will change the characteristic of the carrier signal depending upon the input signal. So you can say to generate different waveform with a wide range of frequency, this is the function of function generator, and they are using that feature for a modulating also. So option C is your right answer. Okay, in which mode of operation does the 555 timer continuously generate a square wave without requiring an external trigger? So if we talk about our IC 555 timer, then it has three modes. Okay, three modes. Timer IC, we have timer IC is known as the IC 555. It has three mode. First one is your A stable mode. Next one is your mono stable mode. Okay, mono stable mode, and the third one is your bi stable mode. Okay, in A stable mode there is no stable state. Okay, there is no stable state in A stable mode. In mono stable we have one stable mode, as it is named as a mono only, so it has one stable state. And bistable, bi means two, so it has two stable state. Okay, a stable timer IC 55 timer, it produce square wave. It produced the square wave. Okay, And mono stable with produce one pulse only, one pulse. It produce one pulse only. And bistable act as a flip flop. Okay, because it has two stable state, so it act as a flip flop. So these are the things related to IC55 modes. So here they have asked about what? A square wave generation. So square wave produced via astable multivibrator or astable mode of 555. So option A is your right answer. Okay. In a power supply, what is the effect of increasing the value of filter capacitor? So in a power supply, what is the effect of increasing the value of filter capacitor? That will be your ripple voltage. Okay, that will be your ripple voltage. So due to ripple voltage at the output, like due to ripple voltage only, uh, it will increase the value of filter capacitor and output will be decreased due to ripple voltage. Okay, so option D is your right answer. Okay, what does the integral of a power spectrum density of a signal over all the frequency representation? So if we, here they have asked integral of power spectrum density. So integration of power spectrum density, generally we will show like this: s of sx of app df, and integration it will go plus infinity to minus infinity. Okay, this is what, this is PSD, power spectrum density. So this is called average power. Okay, total average power, it is called integration of PSD is called total average power. Option A, the signal average power is the integration of PSD is called the signal average power. Option A is your right answer. Now the next one is, if the maximum frequency of a baseband signal in a what AM signal is FM. Okay, how much bandwidth needed overall to send the modulated signal? So here they have asked for what? AM signal, AM system. So generally we have bandwidth of AM, that is equal to twice of maximum frequency. So option B is your right answer, twice of FM. Okay, which of the following best characterize the narrowband FM signal? Okay, so narrowband FM, so FM, that is your frequency modulation. Generally this frequency modulation we have a two type. First one is your narrow band FM, and we have wide band FM. Okay, two type of uh, band is there in FM, narrow band FM and wide band FM. So in that case, in a frequency modulation modulating index. Okay, modulation index, we have modulation index that we will denote as a beta. So beta is equal to what? Del of f divided by fm. Okay, this del f is called as a frequency division, and this one is your modulating frequency. Okay, whenever this beta is less than 1, then it will called as a narrow band fm, and this beta value is greater than 1, this then it will called as a wide band app. Okay, so just remember this point: when this beta value modulation index is less than 1, then FM is called as a narrow band FM, and modulation index is greater than 1, then frequency modulation is called as a wide band FM. Sometimes they will ask about bandwidth also, so you need to remember about bandwidth. So bandwidth of narrow band FM is twice of FM, and bandwidth of wide band FM is equal to twice of del F plus FM. Okay, this is the formula. So from here they have asked about narrow band FM. So narrow band FM is less than 1. Okay, modulation index is what? less than 1. Beta is less than 1 in the narrowband approach. All right, next question. So next question is what? Which simple form of digital amplitude modulation is commonly used for transmitting binary data? So in a digital modulation AM technique, if we talk about digital modulation AM techniques, okay, digital modulation AM techniques, we have ASK, that is your amplitude shift keying. Then we have OOK on off keying. Okay, then we have QAM, quadrature amplitude modulation. Okay, in ASK it carries amplitude. Okay, it carries amplitude changes, it carries amplitude. Okay, okay, that is your on off keying. In that carries on for binary 1 and off for binary 0, as it name as a on off keying. So for on it will carry binary 1, okay, and for off it will carry binary 0. Okay, for op it will carry binary 0. Quadrature amplitude modulation, in that case both amplitude and phase carrier varied. Okay, both amplitude amplitude and phase of carrier varied. Okay, in amplitude shift keying only amplitude carrier of the amplitude varied. Okay, in on off keying it will carry on when binary 1, it will carry off when binary 0. And in quadrature amplitude both amplitude and phase of the carrier will be varied. Okay, so here they have asked about what? Here they have asked which simple form of digital amplitude modulation is commonly used for transmitting binary data. So binary data, binary 1 and binary 0 is transmitted by a OOK, on off keying. Option D is your right answer. Okay. Which component is involved in the conversion of an input radio frequency signal to an intermediate frequency in a super heterodyne receiver? So super heterodyne receiver, I think you know the block diagram. Okay, this thing are also important. In last time interviewer they have asked just draw a block diagram of super heterodyne and explain each block, like that they have asked to one candidate. Okay, so this is what RF amplifier. Then we have mixture we have. Then we have IF amplifier. We have IF amplifier. Then we have detector. Okay, after that we have audio amplifier, audio frequency amplifier. Okay, then we have loudspeaker, you can say, or LS loudspeaker. And in mixture we have one more thing, that is your local oscillator. So this is the super heterodyne block diagram. And here it's asked what? Which component is involved in the conversion of the input radio frequency signal to a intermediate frequency? Okay, so input we have RF amplifier, then it is going through a mixture, then we are getting IF, that is intermediate frequency. So we can say mixture is your right answer. Option A is your right answer. Okay, how does impedance transformation in an AC circuit enhance power transfer? So we know the maximum power transfer, that is your RL equal to RS. Load resistance is equal to source resistance. Okay, so it enable maximum power transfer by analyzing source and load impedance. Option C is your right answer. Okay, what does the mutual information signify between two random variable x and y in the context of information theory. Okay, so in the context of what information theory, if we talk about mutual information, so it will measure how much information one random variable, that is x, is provide about another random variable, that is y. So what it will do, it will generally it will give the information about x or y. It will sharing the information between x and y. So you can say the amount of information that x and y shares, that thing only called as a mutual information in two random variable x and y. It will share the information of x and y. Okay, option B is your right answer. Next one is the quantization noise in pulse code modulation PCM is mostly affected by the which of the following option when the input signal is random process. Okay, so generally quantization noise in a PCM is mostly affected by the number of quantization label. Option C is your right answer. Okay, now the next one is next question. When a clock minute hand moves, its shaft twists slightly, generating a torque portion proportional to the angle of twist. What physical property determine the torque in the clock shaft? So that will be what that is known as a transitional stiffness of the shaft. Okay, so that is your answer. Option B is your answer. In a system with a negative feedback loop, how does the overall gain behave when the gain of the feedback path is positive? So how it will be behave generally when when in a negative system, negative feedback loop has, then the overall gain in this case when positive path, when we have a path of positive, so in this case in the negative feedback path it will decrease, it will decrease overall gain, it will decrease overall gain, it will improve stability, it will improve stability and bandwidth, and it will reduces distortion, it will reduces distortion, or you can say noise. So this thing will happen, or this thing will affect or behave when gain of feedback path is positive. In the negative feedback amplifier, when the feedback path is positive, that time it will decrease overall gain, it will improve stability and bandwidth, and it will reduce distortion and noise. Okay, so from here you can say overall gain will be decreases. Option B is your right answer. Okay, in an electric motor, in an electric motor, the input is an electrical signal and the output is mechanical motion. What does the transfer function? Okay, transfer function of a system, generally how we are calculating transfer function of a system, that will be Laplace transform of output divided by Laplace transfer of input. Okay, so here they have mentioned input as a electric voltage. Okay, input is a electric voltage and output we have mechanical, mechanical we have output. Okay, so we can say the ratio of mechanical output to electrical input. Option B is your right answer. Okay, now the next one is your, in a control system, a summing point with two input A and B produces an output Y. What is the output of summing point if both input A and B are positive? So summing point generally we will denote like that, and in the question it's saying one is A and another we have B. So what is the output? So output generally after summing, that is y, is equal to, it will be a plus b only. Sum, it will be summing operation, so output we will we will get a plus b. So the sum of a and b. Option B is your right answer. Okay, how many forward paths are there in given signal flow graph SFG? So in this graph, you if you see forward path we need to find. So forward path, how we will calculate? We will go from RS to YS, means input to output we will go, and we'll see how much path we have which are not intersecting another nodes. Okay, and it is going till input to output. So you can say we have G1, G1, G2, G3 and G4 only. Okay, so option B is your right answer from here. One path we have, one forward path we have in this SFG diagram. A proportional control system is used to regulate the temperature of a heater by adjusting the on-off cycle time. What is the main feature of a proportional controller in a temperature regulation? So proportional controller, that is belongs to your PID controller. So here it's using P controller, means proportional controller. So that will happen when it regulate the temperature of a heater by adjusting on off cycle. Then the feature of a proportional control in a temperature regulator is will be reduce the power supply once the temperature reaches the set point. So when you will do on off cycle time, so once it will reach to set point, after that it will reduce the power supply. Okay, so option B is your right answer from here. Now the next one is what? While analyzing the stability of a control system using Routh criteria, what does a sign changes in the first column of the Routh table indicate? Okay, if we talk about RH criteria, so RH criteria we have. RH criteria is a mathematical method to used to determine the system stability, used to determine system stability. Okay, used to determine system stability. And like we have some condition here, as they have asked question, so we'll understand by a condition. Okay, suppose if no, first one is what? First one is if no sign changes, if no sign changes. Okay, there will be no sign changes is there. In that case, all poles in LHP, left half of the plane. Okay, and in this case it will be stability, it means the condition will be stable. Okay, and another one, if suppose one sign changes. Okay, if suppose one sign change, okay, if one sign changes occur, then one pole in right half plane. Okay, one pole is in right half plane, and in this case the system will be unstable. Okay, unstable. Same if it will go to two sign changes is there. Okay, two sign changes is there. In that case, two pole is in RHP, right hand plane, and this time also it will be unstable. Okay, so from here we can say number of sign change number of sign change in first column, number of sign change in first column is equal to number of pole in RHP, that is your right half plane, and in this case it will be unstable. Okay, unstable. So just remember this thing, any sign will be changed, then it will go to right half plane, and the system will be what? Unstable. So here it's asked like what does a sign change in the first column of the route apple. So if sign will changes, then it will go to right half plane. The root is the closed root in the closed right half plane. So option A is your right answer. Okay, next one is a Nyquist plot of a system does not encircle the point -1 plus J0, and there are no poles of the open loop transfer function in the right half of the S plane, what can be concluded about the stability of the system? So same thing, here also it's mentioned like open loop transfer function, and it will be in the right half S plane. Okay, right half S plane. What it is saying, there are no poles or open loop transfer function in the right half plane, means there is no any kind of pole is present in the right half plane. So all poles are in left half plane. So in this case it will be stable, as we have discussed before. It will stable, the system is stable. So we can say option A is your right answer from here. Okay, now the next one is, what does the body plot of a system represent where h of w in the system frequency response? What does the body plot of a system represent where h of w, h of omega, yw, h of omega is the system frequency response? So generally in a body plot is a, we know body plot is a logarithm frequency response, which plot magnitude and phase both. Okay, so it will plot both magnitude and phase. So generally we have h of w omega is mod of h of omega and e phi omega. Okay, so here this h of omega we have that mod wala, this will called magnitude response. Okay, and this phi omega we have, this phi omega is called phase response. Okay, phase response. So from here we can say it will represent magnitude and phase of h of omega versus frequency. So option A is your right answer. Both it will represent amplitude or phase. Okay, now if P is the number of open loop poles and Z is the number of open loop 0, what is the number of roots, locus, branches when P equal to Z? P is what? P is your number of open loop poles and Z is your number of open loop 0. So in that case, what will happen when P equal to Z? Then all root locus branches originated from the finite loop poles and terminate at the final open loop 0. Option A is your right answer. Okay, next one is your, for an LTI system with impulse response h of t, what does the output become when the input is a unit step function? Okay, so for a LTI system with impulse response h of t, what does the output become when the input is unit step function? So the output is convolution of the impulse response with the step function. Okay, what will happen? The output will, like y of t is there. So y of t will become, we have impulse response, that is we have h of t, it will be convolution of your step function, that is you can say uft. So the output will become, what output will be the convolution of impulse function and step function. So here option, which one is convolution is what, or you can say this one in product of unit step function and h of t. This is the product or convolution, or convolution is there. So option B is your right answer. Okay, option B is your right answer, convolution of h of t with the unit step. Okay, further you have a formula for this also, h tau d of tau. Okay, and this will go t to, I mean minus infinity to t. Okay, so your answer will be option B, convolution of h of t with the unit step. Okay, now the next one is a robotic arm using PID controller. A robotic arm using PID controller to maintain a precise position despite external distribution. How will the motor adjust its input based on the PID control strategy? So this will be done by adjusting the input proportionally, integrated past error, and predicting future error. By adjusting input proportionally, integrated past error, and predicting future error. Option B is your right answer. Okay. An electric circuit consists of two capacitor and one inductor. How many state variable are required to describe this system? Okay, so capacitor and inductor, if we talk about capacitor and inductor, so both are energy store devices. Okay, as we know, both are energy store devices, either it is capacitor or inductor, both are energy store devices. So number of state variable required to describe the system will be number of element. Okay, number of state variable is equal to number of store element. Okay, number of storage element. So C and all both are storing element, and here two capacitor and one inductor. So total three element are using. So option C is your right answer. Okay. A PI controller is implemented in a system with a unity negative feedback. What is the primary role of the integral action in a PI controller? Okay, so generally, if we talk about PI controller, or if we talk about our controller type we have. So controller type we have P controller, that we call proportional controller. Then we have PI controller, that we call proportional plus integral controller. Then we have PD controller. PD means proportional plus derivative controller. Then we have PID, that is your proportional integrated derivative controller we have. Okay, so in P controller or proportional controller, it will reduce rise time. Okay, it will reduce rise time. PI, that is proportional integral, it will reduce steady state error. Reduce steady state error. Okay, it will reduce steady state error. PD will improve stability. Okay, it will improve stabilities. And PID, it will be combination of all. Okay, combination of all things. So combination of proportional, this means combination of proportional, integrator and derivative, it will do that thing. Proportional will reduce the rise time, PI will reduce the steady state error, and PD will do improve stability, and PID have all the facility. So here they have asked about PI controller will reduce the steady state error. So option B, it decreases steady state error. Okay, option B is your right answer. Okay. Now the next one is, in a lag compensator circuit, the output voltage is by determined is determined by the current flowing through the series connection of a resistor and a capacitor. What is the primary role of a capacitor lag compensator? So that will decrease the settling time. Actually, it will decrease the settling time. Option B is your right answer. Okay. Now, amplitude shift keying, that is ASK. How is logic 1 is typically represented in binary ASK? Okay. So, if we talk about our ASK, that is amplitude shift keying, in that logic 1 is represented by the presence of a specific amplitude. Okay. One. Logic 1 means what? Logic 1 means what in binary ASK, we are talking about binary ASK. In binary ASK, logic 1 is represented by the presence of a specific amplitude. Okay, then we have logic 0 also. Okay, logic 0 means it will be absence of zero amplitude, zero amplitude. Okay, logic 1 is the presence of a specific frequency or a certain frequency, or logic 0 is a absence of a zero amplitude. Okay, so from this option you can say by associating a certain or a specific amplitude to the carrier wave. Option D is your right answer. Okay, now the next one is your radar system. Okay, a radar system, a radar system sends output, a radar system sends out a specific signal to detect object in the environmental. Okay, that we know radar will send the signal and it will detect by like object, it will detect in the environmental. The received signal is noisy and the system uses a matched filter to identify object by minimizing signal to noise ratio. What is the primary purpose of using matched filter in a radar? So what is the function of a matched filter, that is asking in a radar? So by using matched filter it will minimize the signal to noise ratio and it will accurate detect the that noisy in the noisy environmental also, it will accurate detect the object. Okay, so you can say it will minimize the signal to noise ratio for accurate detection in noisy environmental. Option B is your right answer. That's why we are using matched filter. Okay, which method is most accurate for analyzing error performance for a wireless network in a multi-path fading area that needs error performance analysis? Okay, so that will we are using by a Monte Carlo simulations. Okay, Monte Carlo simulation, by using that only this method we are using for analyzing error performance for a wireless network in a multipath fading area that need error performance analysis. Now the next one is, which of the which of the following is a step involved in encoding message using Hamming code? So Hamming code, why we are using Hamming code? Hamming code is used to control or will calculate the redundant bits. Okay, will calculate the number of redundant bits. Option B is your right answer. The time division multiple access, TDM, the time division multiple access, that is your TDM system, where user are assigned a specific time slot for transmission. The system operates under centralized control where the control nodes synchronize the time slot for each user. Why does TDM require guard time between user transmission? So many questions you have seen, only the purpose, main purpose of them to ask this thing only, but they are like they are writing so many things that there is no use of that one. By reading this question also, by reading this sentence also, you can give the answer, like why does TDM require guard time between user transmission? Because to prevent overlap user transmission due to phase differences using guard time. Generally we will use this guard time to overlap of transmission, to prevent the overlap of transmission. So option B is your right answer. Okay, now which principle is responsible to ensure the quantum information is secure from the unauthorized replicant? So we have no cloning theorem we have, as they have mentioned about securing from the unauthorized replicants. So we are using no cloning theorem. So in the no cloning theorem, what it will do, like it will work as a quantum mechanism which state it is impossible to create identical copy. You can't make any clone of another, like any attributes. Okay, for any attribute you can't make any clone or copy things. So for that no cloning theorem is there. Okay, so this will be help for quantum information security purpose for unauthorized replication. Option A is your right answer. Okay, now which which feature of the Zener diode makes it suitable for use compact circuit and mobile phone application? So we know Zener diode will give the regulation, I mean voltage regulator, efficient voltage regulation has a property of Zener diode that will make suitable for use of compact circuit and voltage mobile applications. Okay. Under which condition does the bipolar junction transistor operate in a saturation region? Okay. Now in BJT we have some modes or region. Okay. We have four kind of modes or region in the BJT, that is your saturation. Okay. Saturation region. Then we have cut up region. Okay, then we have active region. Okay, then we have reverse active region. Okay, four kind of region we have: saturation, cut up, active and reverse active region. Now when junction is biased, like emitter bias junction is there, like a junction will be in emitter and bias, then another one is biasing by base and collector. So when both the emitter bias and uh, emitter to bias and bias to collector, when both the junction are forward bias, okay, when both things are forward bias, in that case it will work in a saturation region. When in this will be in reverse bias and this will also in reverse bias, then it will work as a cut-up region. When this one is a forward bias and this one is a reverse bias, then it will work as a active region. When this one is a reverse bias and this one is a forward bias, then it will work as a reverse active region. Okay, so these are the conditions that you need to remember. Here they have asked about what? Saturation region. So in the saturation region, collector base junction and emitter base junction both are in the forward bias. Okay, both are in the forward bias in the saturation region. Both are in the forward bias. Sometime they will ask question about application. When transistor is in a saturation region, then which application is in what purpose we are using in a saturation region? So in on switch. Okay, on switch. And cut up used for off switch. Okay, off switch. Then active region, in active region transistor act as an amplifier. Okay, act as an amplifier, and in the reverse active it will act as a attenuator. Okay, attenuator, this also you need to remember. Okay, this full table you need to remember. This time also they are going to ask question from this table, because every time in every BL exam you will take whatever exam it is, they have asked question from this table only. Okay, one question will be there, one or two question you will get from this table. So just keep this table in your mind. Okay, now the next one is your what? Which condition determine the threshold point for a MOS capacitor? Okay, which condition determine the threshold point for the MOS capacitor? So that will find by a bulk doping concentration, or you can say the condition when the surface electron concentration is less than, okay, surface concentration electron is less than the bulk doping concentration, then threshold point will be determined. Okay, so option B is your right answer. What fundamental principle is used to determine the equation for each mesh when applying mesh analysis to determine the current in a circuit? So for mesh analysis we are using KVL, that is Kirchhoff voltage law, and for nodal analysis this is for mesh analysis, and this is for nodal analysis we are using KCL. Okay, so from here option A is your right answer. Okay, in which operating region is the bipolar junction function fully on and work effectively as a switch? So in two condition only transistor work as a switch, as we have discussed just now, in saturation region and in cutoff region. Okay, so in saturation region it is work as a on switch. Okay, and in cutoff region it is work as a off switch. Okay, just now I told you in that table they will ask so many questions, so you need to remember that table. Okay, so option C is your right answer from here. Okay, now the next one is, which of the following describe an optical property of photodiode? If we talk about photodiode, what is the function of photodiode? Photodiode, what it will do, it will convert light into a electronic current. Okay, so from this thing, from this definition only, you can say a measure of sensitivity of light. Okay, so it will describe the optical property of a photodiode. Option C is your right answer. Now, which type of sample and hold circuit is specially designed for application like analog to digital converter, where precise timing is critical for accurate signal processing? So it will be done by your pulse sample and hold circuit. Option D is your right answer. In which operating region does a bipolar junction transistor function effectively as an amplifier? So just now we have discussed in active region transistor work as a amplifier. Okay, so option A is your right answer. Okay, now the next one is, which type of memory is best suited for digital electronics application where high storage capacity is required at a low cost? So for storing we have different type of memories in a digital, but when we need high storage capacity at low cost, then we have DRAM. Okay, then we have DRAM, that is dynamic random access memory, will use for high storage capacity at low cost. Okay, now the next one is your, what term refer to the duration a microprocessor takes to access memory or input output devices and completed the associated read or write operation during the operation? Okay, so this cycle actually we will call machine cycle. Oh, that is your option C. Machine cycle is equal to what? N into T states clock cycle. Okay, clock cycle, that we called machine cycle. So generally whatever performance or operation will do in microprocessor, that will be completed like read or write operation or anything, that will be done by machine cycle. Okay, and some other cycles are there, like we have instruction cycle and fetch cycle and execution cycle. This equation you need to remember. Instruction cycle is equal to fetch cycle plus execution cycle. Okay, now the next one is, which controller is specifically which controller is specially developed for interfacing keyboard and display device for the Intel at 0 at 5? So 8279 Intel have a 8279 microcontroller that is developed for interfacing keyboard and display devices. Okay, which reset mechanism is designed to which reset mechanism is designed to activate when the supply voltage drops below a predefined threshold? Okay, so we have some different kind of mechanism or reset type is there in the microcontroller, that we have reset type. If we talk about reset types, then we have POR, that is your power on reset. Then we have BOR, that is brown out reset. Then we have WDT, that is your watchdog reset, and we have external reset. These are reset type are there in the microcontroller. Power on reset, brownout reset, watchdog reset, and external reset. Okay, and it will be power on reset is there. So it will be triggered by first application power. Okay, when it will be trigger, when application like first application will be powered, that time it will be triggered power on reset. And bor means brown out reset, it will be triggered when supply voltage drops below threshold. Okay, it will be drop below threshold. Then we have wt, that is your watchdog reset we have. So when or hang software will crash or hang, that time this reset will work, wdt. And the next last one we have external reset. So this will trigger by external pin. Okay, so here in the question they have asked about what, which reset mechanism is designed to activate when the supply voltage drop below the predefined threshold. So supply voltage drop below the threshold, that will be defined by the bor, that is brown out reset. Apart from that, I have discussed all the reset type that you need to remember for the next exam. Okay, in which mode of operation in which mode of operation does the configurable logic block CLB produce two independent function, each involving four variables? So that will be done by FG mode. FG mode means function generator mode. Okay, option A is your right answer. Which forces is experienced by the holes represent under the oxide layer when positive gate voltage is applied to the semiconductor surface to the MOS capacitor of MOSFET? So here it's saying holes present. Okay, by the holes present. So holes is what? Holes is having positive charge carrier. Holes have having positive charge carrier, and here we have positive gate. Okay, positive gate voltage we have, so both are positive. So in that case it will generate repulsive repulsive force. Okay, it will generate a repulsive force. So option C is your right answer. Okay, now the next one is in the node analysis method. In the node analysis method, what is the recommended characteristic of a reference node? So the recommended characteristic of a reference node is having zero potential. Okay, or you can say it should be connected to a ground or have zero potential. Option A is your right answer. Okay, the superposition theorem is particularly useful in which of the following type of circuit? So superposition theorem generally we are using where we have two or more independent sources. Okay, if we have two and more independent sources, or you can say multiple independent sources, in that case we are using superposition theorem. Option B is your right answer. What does the pointing vector represent in the electromagnetic theory, and how it is direction determined? Okay, how it is direction determined? So generally that we will be done by power flow per unit area. Okay, option C, you can say the power flow per unit area with direction perpendicular to both electrical and magnetic. Okay, so option C is your right answer from here. All right. Now the 78 is what? How does the current through the capacitor behave in a DC circuit when circuit reaches a steady state? Okay, so it will be behave as an open circuit when the circuit will reaches as a steady state. So capacitor will be behave as a open circuit, and capacitor will when it will be in a open circuit, then current will be 0. So you can say here somewhere any option is there, it will become 0. Current will be, here they have asked about current flow. So current will become 0. Option C is your right answer. Okay. Now this one. For the resistive circuit, Yt equal to B, Yt equal to B f of T. What condition ensure the system is time invariant? So this B should be, for time invariant, this B should be constant always. Okay, it should be constant. B must be constant always. Then it will called as a time invariant. Option B is your right answer. Now, what is the resonance condition in a series RLC circuit when analyzed in the frequency domain? So resonance condition means what? We have XL equal to XC. XL equal to XC, that is your XL means inductance. Option C is like inductive reactance and capacitive reactance. Option C is your right answer. The inductive reactance is equal to capacitive reactance. This is the resonance condition in RLC circuit. Okay. For an amplifier, for an amplifier characterized by the H parameter equivalent circuit, the voltage gain is influenced by. So for voltage gain, so for voltage gain, all four H parameter is will be characterized like H11 we have, H22 we have, H21 we have, H12 we have. So for voltage gain, it will be characterized by all four H parameter. When we will talk about current gain, so for current gain, it will be H21 and H22. Only two parameter are required. So here they have asked for voltage gain. So option D is your right answer. Okay. Now the next one is, what happens to the Fourier series representation if the period t of the function approaches infinity? So when the t of the function approaches infinity in the Fourier series, so it will become Fourier transform. So option B is your right answer. Fourier transfer, it will become Fourier transfer. So option B is your right answer. Okay. Now the next one is your, what? What is the relation? What is the relation between impulse response h of n of a system and its frequency h of e z omega, e to the power j omega? It is h of e to the power j omega. So h of n, it's asking about h of n. So generally it will call the impulse response in the inverse dt ft of the frequency response. Okay, that we called I T T F T. So this is the relation. Okay. Now the next one is your, which of the following represent the region of converge ROC of a causal sequence in a Z domain? So ROC will be defined by outside of the outermost pole, which will represent the ROC in a causal sequence in a Z domain. That should be outmost, like outer side of the pole. So option C is your right answer. Okay. Now the next one is your, what happened to the output of LTI system when input is delayed by T0? So generally what happened when LTI system like in the output of LTI system, when input is delayed by t of 0, then the output will go t0. The output is delayed by t0 only. That is the answer, option C. Okay. Next one is your, in a multi-stage amplifier, why is the coupling of stage typically done using capacitor? Okay, if we talk about multi-stage amplifier, so multi-stage amplifier consisting of two or more amplifier, that we know. Multi-stage means we have two or more amplifier stages that are connected or in a cascade way. Okay, we have amplifier that will be connected in a what like cascade way, it will be connected. Okay, so the output of one stage is connected to the input of another stage, like that it is there in a multi-stage amplifier. So if we connect directly to all the stage, then the DC bias of one stage will affect the next stage. Okay. If, like here in the question is asking why coupling stage typically done by using capacitor, and why it is done, because if we not done this thing, then it will affect to the next stage and noise will come. So we use capacitor, coupling capacitor between the stages to block DC component between stages. Okay, so option A is your right answer. We will use DC, I mean coupling capacitor to block DC component between stages. Okay. Now the next one is, which of the following condition ensures no signal distortion in an LTI system? Okay, which of the following condition ensures no signal distortion in an LTI system? So we have linear phase response and group delay, consonant group delay. That the condition ensures no signal distortion in LTI system. Which window function which window function reduces the ripple amplitude in a frequency response but result in slightly rose cut-up slope? So it will be done by Hamming window. Option C is your right answer. Okay. In a parallel structure of two LTI system, the transfer function h of 1 and h of 2, the total system transfer function they are asking. So it is a parallel condition. So whenever we will connect this h1 of s and h2 of s in parallelly, okay, like that, if we connect like that, and then it will what, the output will come, the total transfer function will be calculated by summation of h1 s and h1 2. Okay, this is the summation of h1 on h1 2. That is your answer, option A. Similarly, if they will give this thing in a series, okay, h1 of s and h1 of 2, h2 of s. Okay, here in the question they have asked it will connected at a parallel structure. So in that case, in this case, it will be summation of h1 of s and h1 of h2 of s. Similarly, if they have given for series structure, so for series structure, in that case, it will be multiple. It will both will be multiply. Okay, h1 of s and h2 of s will be multiply, or dot, you can say option B, like that you can say. So option A, from here option A is your right answer. Okay. Now, which law describe the relationship between time varying electric field and magnetic field in a free space? So when we talk about time varying electric field and magnetic field, then it's related to your Ampere's law. Okay, it's related to your Ampere's law. So that is your answer. Okay. Now the next one is your what? Next question is about radar. What is the key function radar system in term of object detection? What is the key function of radar system in term of object detection? So radar, generally radar, what will we do? If we talk about radar, Radar is what? Radar is your radio detection and ranging. Okay, radar is what? Radio detection and ranging, and it is used radio wave. It will be used radio wave. It will transmit radio wave, and it will detect or locate or track the major object. Okay, so we can say from here, radar transmit electromagnetic wave and analyze the reflected signal to detect the object. That is a function of key function of a radar. Option B is your right answer. What does impedance matching ensure when wave travel from one medium to another medium? So when it will travel from one medium to another medium, that time it will observe a complete absorption of the wave energy at the boundary. So option B is your right answer. Okay. Now the next one is, in a simple charge free medium, what is the relationship between electric field E, magnetic field H, and the wave vector K of a time harmonic plane waveform? So in a simple charge carrier and source free medium, the electric field, magnetic field, and wave vector, that is your K, are mutually all are perpendicular. E perpendicular to H and perpendicular to K. Okay, so option C is your right answer. E and H are both perpendicular to K, or both are, means all are perpendicular to each other. Okay, which property of transmission line helps in minimizing signal loss during trans power transfer? So during power transfer, impedance matching, when the load actually it is the answer for like, you can say proper impedance matching. The property of impedance matching is there for transmission line. It will help to minimize the signal loss during the power transfer. Okay, so generally for a power transfer, this load impedance should be equal to characteristic impedance. Okay, ZL equal to Z naught. Load impedance should be equal to characteristic impedance. Okay, in that case, maximum power will transfer. Okay, maximum power will transfer, and one more thing, reflection will be 0. Okay, reflection coefficient will be 0. So whenever ZL equal to Z naught, load impedance is equal to characteristic impedance, in that case maximum power will transfer, and that reflection coefficient will be 0. Okay, how does the Smith chart simplify impedance mismatching in a transmission line? Okay, so generally it will be like same, you can say by graphically representation of reflection coefficient and normalization impedance. That reflection coefficient that we have discussed just now, that will be ZL minus Z naught divided by ZL plus Z naught. Okay, ZL is a load characteristic impedance, and Z naught is a what characteristic impedance. Okay, ZL is load impedance. ZL is load impedance, and Z naught is your characteristic impedance. Okay, so from here option B is your right answer. Now, which mode is supported in coaxial cable but not in rectangular waveguide? So we have TEM, that is transfer electromagnetic. TEM we have, in that it will supported in coaxial cable, but it will not support in rectangular waveguide. Okay, which antenna type is primarily used for high gain applications such as satellite communication and radar system, offering a narrow beam width? Okay, so actually this is called as a parabolic antenna. Okay, this is called as a parabolic antenna. And if we talk about parabolic antenna uses parabolic shape to focus EM wave into a narrow beam, providing very high gain and directivity. Whatever mentioned here, That is the function of your parabolic antenna. It will provide high gain and directivity, high directivity. Okay, so for high gain application we are using parabolic antenna. Okay, option B is your right answer. What is the effect? What is the effect? What is the effect of using an antenna array with multiple element of an overall bandwidth, beamwidth? Okay, so what is the effect of using an antenna array with multiple element of an overall bandwidth? That will use multiple element narrow and beamwidth will increase directivity. Okay, so this will the effect of antenna array. Option A is your right answer. Which radar system is primarily used for detecting moving object by measuring frequency shifts? So for moving object, simply we are using Doppler radar. Okay, we are using Doppler radar. Apart from that, we have some radar type also. All right, radar type we have some CW radar we have. Okay, CW radar. Then we have pulse radar. Okay, then we have Doppler radar. Then we have MTI radar. We have SAR radar. We have phased array radar. We have phased array radar. So these are some kind of radar we have. So for primary for moving objects, like to detecting moving objects, generally we are using Doppler radar. Option B is your right answer. Okay, what mechanism ensure the light signal remain confined to core of an optical fiber? So generally it is asking what is the principle behind the optical fiber, how light is traveling. So that will be travel, that principle will be your total internal reflection within a core. Okay, we have core and cladding in the optical fiber, as you know already. So that total internal reflection is there in the core. Due to that mechanism, optical fiber will work. Okay, so from here total internal reflection within the core. All right. Okay, so as you have seen, we have completed our 2025 paper also, and previously already I have discussed 2023. Those who haven't completed 2023 electronics probationary engineer previous year paper, just go in the playlist, you will get this one and complete this one also. And general aptitude I already covered for 2023 and 2025. Now it's time to do analysis. So in subject wise, if you see subject weightage of your exam, so when I solved 2023, that time also I considered this analysis, and this 2025. So here these are the weightage. Like from this section they have asked question mostly. Like if you see communication system, analog device and circuit, control system, digital electronic signal system, and EMFT and network theory and circuit. From these topics are most of the major topic, you can say, from question they are asking repeatedly, and weightage will be more in both the year. You can see the compare also, and some rest chapter are also there, so you need to prepare all the chapters. Okay, and for non-technical, as I have covered that time also, I told you this is the non-technical weightage they have asked in 2023 from reasoning and GKGS only, but in 2025 they have asked question from aptitude, reasoning and English. Okay, no GKGS question in 2025. So these are the weightage of that thing. So the thing is, you need to cover all the things from this app material which I gave you. I hope so many like many of people have taken already. So here you will find one ebook. In that you need to prepare subject wise, like whatever subject you have here, these many subject you need to cover. So subject wise notes is there, and subject wise MCQ is there. So whatever things are required for this exam, okay, you for this exam, as you have seen 2023 paper also and 2025 also, for clearing this exam you should have a good concept of each subject and fundamental things you should know. The basic thing you should know about every topics. Okay, so that much only it is written in that ebook. Only key points it is written. No extra, no less things. Only whatever required for BL probationary exam, that much it is written there. And after that, same level of MCQ is there, subject wise MCQ is there with details answer explanation. Okay, that you need to cover. After that, 500 important technical MCQ is there. Last year also so many question came from this important sets. So I have added some more questions here, and that you need to cover. Okay, here you will get technical 500 important question and expected question that are with details answer and explanation is there. So in this section only you will get mock test there. Only technical mock test is there that you need to cover. Okay, technical test series. Then 150 important GA, I mean general aptitude section is there. As we know, 25% they are going to ask from general aptitude also. So this section is also there. That important question you need to cover. Apart from test series is there in that section related to general aptitude. Only non-technical question is there that you need to appear. Then full mock test series is there. Okay, full mock test series means 125 question is there. 125 question like that. 5 set is there. 5 test series is there that you need to perform. In that all five test series important questions are there. Okay, just do that one, check your level how you are doing. And this what I solved today, I already provided you previous year question. And this solved paper you will get in app only. I will attach in app, you can check from there also. Like you can see sometime, if you need you can just go to app and check that answer how the solution and all. And important interview and question, anyhow interview we will discuss when after written exam we'll do some other classes for that also. So these all these thing you are going to get in an app. This is the Mann Maker app. You can download directly from the Play Store or just go to below description box, there you will get link, from there you can download. And this is my WhatsApp number. If you find any kind of help, doubt or anything, you can directly message to me. This is my personal WhatsApp number. Okay, and subject wise classes is going on. As you can come to my channel here, BL Probationary Engineer classes is there. In that for electronic section, this is the playlist. For electrical, this is the playlist. Computer, this is the playlist. And general aptitude you need to cover also. So general aptitude classes also there. So all video classes you will get here only in YouTube. But you need to practice all the questions from the app. Okay. So that is the thing. Okay. So I hope you enjoyed this class today. I have completed this previous year and I think you got all the answers in a better way. So if you like the video, just hit like on a button, kindly share with your friends. And if you not subscribed my channel till now, just subscribe the channel and press the bell icon. Okay. Thank you.